Hi everybody, this is Steve with the Commodore 64 Game Project. Welcome aboard. In this series, we're going to be covering the Commodore 64 Game Project Video 2. We're going to be learning how raster interrupts work on the display and manage and scan lines that run down the screen with our own user-defined interrupts. And we're also going to be introducing a joystick in this series so we can move the screen around. And another thing I've added to this one is the ability to basically project one screen and then switch to another screen, like alternating back and forth. This is known as screen transitions, and it's used whenever you want to be able to scroll like a lot of data at a time, because if you're trying to scroll data, it's interfering with the timing of the computer. So if you're able to move the screen back and forth and move back and forth between them, it's much faster. And finally, I'm going to be showing you how to do the screen scrolling. There are a couple new files being introduced in this series too, but I'll introduce and maybe show you some examples of how the screen scrolls. So it can essentially be scrolled pixel by pixel, up and down, left and right. So let's get this started. As I mentioned in the other video, if you're not an expert in a semi-language, this video isn't going to help you get any better with the semi-language, but I hope that the coding examples, other videos that were released with this series will be pretty helpful to you. The goal here is not to teach you 100% about a semi-language, but to help give you tools that can help you build some of the projects that you would prefer to do yourself. And as always, I appreciate your subscriptions to YouTube, and definitely check out all the action on Facebook. What I'll be doing in this series here is I'm going to be creating a Facebook entry where you guys can go ahead just to that specific post and communicate directly with me about any of your projects and any questions you may have. I'll try to check back with that here as often as I can. So each game project is also going to be available on Github, and I hope you have found that very convenient. So what will be learned in video 2? The goal of these videos is to empower you to create your own games and projects. In this lesson, you will gain the following skills: an in-depth understanding of what interrupts are at work within your system and how you can create your own interrupt programs. This series introduced setting up a joystick controller that will be used while scrolling the map. Next, I will show you screen swapping, which involves switching from a front screen to a back screen buffer. We finally introduce a very important technique that will manage the map screen as it scrolls in the player routines ASM file. These are variables that control the scroll direction as the screen is moving. Finally, the file scrolling.asm holds all the character scrolling, map tracking, and map delta information. And as you've seen from Project 1 and now Project 2, here is the flow chart that you can kind of observe to see what we're going to be covering in this. The changes that were done to main. Anything you're seeing in yellow are changes that I have included as the projects are going forward. So screen underscore mem, which is set at 4000, and screen 1 underscore mem 4000, both of those are being included in this project, and they're being used as pointers to show them essentially where screen 1 memory is being located at. And here is some 0-page pointers that will be used for a lot of different things. They were used in for example, in Project 1, we used them when we were drawing the map. Pointer 1 and 2 are used for the screen displays, and 3 more likely is the color. 4 has its other uses, but those are the kind of the main things. And in this series, they'll be a lot used while scrolling the screen and stuff like that. Now here's a lot more variables that are new. You can see there's current screen, current buffer, scroll count X, scroll count Y, scroll speed, scroll direction, scroll moving, map X POS, map Y POS, map X delta, and map Y delta. To kind of give you a breakdown on this, so the scroll X, scroll count, right here, scroll count X down to here, these are essentially telling the screen when to scroll and things that are going on while the screen is scrolling, like the speed and direction. And down here you see the map X position and map Y position. Of course, those are showing where the map is moving at any given time, whether it's on the X register, which is left and right, or the Y register, which is up and down. And then the map X deltas are also checking the horizontal X and Y vertical to essentially be able to detect things on the map. Like if you're going to bump into a wall, for example, with a sprite later, you'll need to know what those deltas are so you don't pass through the wall. Now we call the subroutine a init raster IRQ that will manage the following interrupts. IRQ top screen manages screen 1 and screen 2 swaps, foreground versus back buffer. Handles vertical and horizontal fine scrolling. IRQ glitch catcher. This is a pointer to screen 6 that displays the debug scoreboard for later in the project. Also, the X and Y scrolling reset points are controlled here. IRQ scoreboard fixes an issue with the jumpy vertical line resolution display as the screen scrolls. And then finally, I have your interrupt 1. This allows free use of an example interrupt. You can create your own work here. An example could be a display of vertical color lines not currently in use. And I'll probably demonstrate that in the code examples here, because I did create one with raster lines. And finally, down below here, we have a new subroutine, a init raster IRQ, which is to set up the raster interrupts. Oh, I'm sorry, those are the main subroutines being introduced: the wait frame, the update scroll, the player state idle, and then down below here we have the new files: the game interrupts.asm, scrolling.asm. So here we set up the system interrupts. These are the keyboard, clock, I/O, disk drive, and there's many more not to be named here. They're disabled, so this is before we begin to set up our own interrupts that will run in the background. Okay, so here is just the main setup for that. And you'll see our first introduction of our first interrupt right here is called IRQ top screen, which we discussed earlier. Oh, and then right here is the raster line. This is where the first raster is taking place at, which you'll see here in a minute. So the first raster is taking place at hex line 32, which is kind of toward the top part of the screen here. And this is just showing some of the setup here. And this is pointing to the screen 2. So it's essentially going to be able to move between screen 1 and screen 2. Screen swapping is resident here to switch between 2 areas of memory. As you saw earlier here, we have screen 1, and this is screen 2. And these are being used by bank 1 to control various areas that exist in memory that you can control. So when you bank out your memory, you're essentially expanding the graphics portability to have more memory available than common when you first turn on your Commodore 64. The ability of this is to be able to create more room for screens, more room for character data, like your redefined character sets, such as in our example we would use from ChartPad. And then you also have anything else later, like your sprites and so on. Scrolling defaults and joystick routine. So this section is going to be managing scrolling default setups, which is what's going on right here. I won't go into a lot of explanation, but these are necessary to be able to track where your lines are being scrolled at the X register. And then here's our first joystick routine, which is being read through our interrupt timing. Basically, so we don't slow down the game while we're moving the joystick. Okay, so now we're at raster line BF, which essentially is our main display on our map. The scoreboard screen is created here. For now, you would notice a black area below the map window set to F800 using bank 1. So this is managing an area down below here, the screen here, And you got to think about these raster lines that are coming down here, and you're basically setting these points of where your programs are going to begin at. Pointer to scoreboard. When bit2 memory is set to bank 1, memory is relocated as you learned in introduction video. The code below sets up the screen panel that will later handle the scoreboard, where you can place a score counter, game buys, weapon, items, extras, and so on. The bank, from bank 1, bit2 is going to be, it's set up like this in, you think of it like in blocks, right? When you're banking out bit 1, you have this 16K area of RAM accessible where you can essentially define your own setup here. And this is why I put down here for bank 1, we have bit 2 plus screen memory. And then after that, we have which is the screen memory is your scoreboard, which goes from hex 5000 to 5800. And then after that, you see the plus. So after that would be the character set, which is 2K, moved from ROM and redefined. Now you can move this screen and this character set anywhere within that 16K block. And down below is our first example of pointing to that blank line I talked about, which will later be our scoreboard. Manage bad lines on display. Now, sometimes you may see in games, Commodore 64 has this little line at the bottom of the screen that kind of flickers on and off. This code, which was originally given by Siggy from the original machine language project, allows that line to be essentially removed. And here we are at raster line C7, and we are managing vertical screen defaults. So you can see that each raster line, each raster, program we're going through here is controlling different things that we tell it to do. And you can create your own, which you'll see here in just a second on the next one. I think I have it in here. Okay, so right here is the rest of the vertical screen scrolling. So the game routines, which we originally created before, now includes these new subroutines. So we wait for the raster line to reach F8. If it's already there, wait for the next screen blank. This allows a very finite management of a screen scroll. You'll see here we got big raster line, and we were talking about the raster lines earlier. You can see there's F8 and F8 here. It looks like they're twice, but really it's controlling this timing area, because if you remove these actually from the project, the screen map will be scrolling real erratically and won't be very fine. Read joystick. This is another new routine we have here. So these are essentially just reading the controller and saving the values, and they'll be used later, as you'll see. And here's our left and right values being saved. So we are finally going to introduce the swapping. So screen swapping, front and back. Screen swapping is managed here. If screen 1 is active, we use the first line. If screen 2 is active, we use the at screen 2 area. If you recall earlier, the screens are swapped with the user-defined interrupt. So you can see here we got the swap screens, which is the first part here. And this is just basically looking for the high bytes. So essentially, if it finds screen 2, it'll go down here. Otherwise, it's going to be able to load into screen 1 immediately. And these are pointers that control the data that's going to be determined in those screens, which we'll see here in a second. Okay, in this section, we are checking which screen was detected so we can begin drawing the tiles to the main display or back buffers I talked about. So down below here, you can see this was the detection line area, and it points to the two different ones here. And now it's going to be going either between screen 1, if it finds it, or screen 2. Front and back buffer. Draw tiles for screen 1 or screen 2. Front screen display map drawing during the main loop. So now that we found screen 1, this is going to allow us to draw this from a table that you'll see here in a moment. And then this is the back screen display, also known as the back buffer, map drawing. And you can see in yellow, this is new because this was in my original video. And this is now allowing us to draw that second screen that they move back and forth between to essentially manage the screen more effectively, so it's not uncontrolled while you're scrolling. And here's our tables, as I just talked about earlier. This is the screen 1 memory tables, and they start from the top. You see it where it says screen mem 40. It's just going from top here, and it's just going down to detect wherever a line is found on the screen. And the cool thing about it is when you add an X here, X register, it can detect whichever line you're going to. So if you wanted to find this line real quickly, you could do it. Like if you were looking at, let's say you were at this line, and you wanted to see what was below on this line, easily you could use this table to find that. And that will be introduced much later when we get into our sprites and stuff. And here's the high bytes. Same technique, except one is the low nibble, this is the high nibble. And now we have color RAM memory tables. And I wrote, note, color RAM memory never moves. Very important to understand that. And here's the high bytes. And it's the same thing too. All this is doing is just going down and detecting, in this example, where the high bytes are being found at. So that you can essentially fill in that color area or that character area on the screen with color. This is going to be later used by our sprites, but for right now, it's going to manage our screen scrolling. So you'll see why they're called player, because later there'll be a player, but for right now, we just have a map only as we go through the progression stages of learning this stuff. So with player setup, we set right, left, up, and down movement limits. This checks when the screen will scroll in the appropriate direction. Now you'll see here we have player right cap, player left cap, player up cap, and player down cap. So when the screen is scrolling to the right, we have to essentially stop it after a certain point. And it's also detecting when the screen can actually start moving too. And if it's going up, it's doing the same thing, and down, it's setting those limits. They're known as boundaries. And here's our joystick ready routine. This subroutine manages if the screen has moved or not, and records the direction of movement to be used in the project when the screen is scrolling, or if it is checking for a scroll. So I talked about these briefly earlier, but the first one here is detecting if your screen has stopped moving. And this one is telling which direction are we scrolling in. So for this, you can tell is it scrolling up, down, left, or right. This one can detect if the screen needs to stop. And of course, this one down here is just saving the value for a scroll direction. Move player right. Scroll the screen to the right, uses mapX_POS variable to check for a boundary limit when scrolling. And of course, again, you're seeing the move player, but player will be introduced later, but for now we're just using it to move a screen. So this is controlling the map movement on the screen. If you look here, you'll see map X position, and here it's checking for a 54. So this is essentially moving the screen to the right here, and as it's moving to the right, it's checking to see when it reaches that 54 byte, whenever it reaches that point, and then it's setting the limits on how far it can go. And then down here, this is setting the scroll fix skip area, which is used by the scrolling routine much later. And this is just more variables being set up for the scrolling here. And you'll see that these are going through them one by one. Now we have move player left. Scroll the screen to the left. Uses the mapX_POS variable to check for a boundary limit when scrolling. And it's the same thing, except this time we're going to the left and we're checking the map limits to the left. Move player down. So scroll the screen down, uses the mapY_POS variable to check for a boundary limit when scrolling. And this one's controlling the down limits with our mapY_POS variable. As you see right here, it's checking how far it can go down. So they're all pretty identical, except for the direction they're moving in. And this one scrolls the screen up, uses the mapY_POS variable to check for a boundary limit when scrolling. And this is the up movement. So it's moving and detecting how far can the screen go up, before it stopped. So this one is if the player is remaining idle, in other words, not moving. First, we check if the joystick to see if it has moved or not by calling joystick ready, and if it has, we advance to the subroutine at input. Now this is really important. I began to understand why this was necessary. If the joystick isn't moving and the map is moving and the character is moving and you're not detecting whether the screen is stopped or not, it will start throwing off the character data on the screen and it'll kind of start ripping the display. So I've learned that these are very important to keep in the subroutine. Joystick left-right subroutine calls. So now we are getting into the left and right movement as a joystick. And remember earlier we saved our values, so now we're checking here to see if this joystick X position movement is in session. And if it has, it'll go to the left, right here, or otherwise it goes to the right, and you see this is the subroutine player state walk right. Screen is moving to the left. And this is the left movement subroutine. Check if the joystick is idle or has been moved up or down. So now we're checking to see if the joystick is sitting in position idle, right, not moving, or if you've moved it up or down. And this will become necessary later when you're actually walking up and down the poles in the game, and eventually I'll be adding ladders much later. So the screen is moving up. This is the subroutine player state walk up. So you see here screen scrolls up or down. And then we're going up, player state walk up. We're going down, player state walk down. Screen scrolls to the right. Now we're into the player state walk right routine. We're checking our idle again. And screen is scrolling to the right. And this is the routine that moves the screen to the right. Move player right. And it moves it by pixels. Screen scrolls to the left, and now we got the player state walk left position. Screen is moving to the left, and the subroutine that calls it move player left, that does the action of moving the screen to the left. Screen scrolls up, that's the player state walk up subroutine. And then down here, move player up is the subroutine that controls the scrolling for that. Screen scrolls down, that's the player state walk down. And the subroutine again here is move player down that controls the scrolling. So here we got the scroll direction, and here you can see it's checking if it's stopped. And then we also got the scroll moving here. And now here, where you see where it says compare scroll right. So if the scroll right variable was found, we can finally start scrolling that screen to the right. The earlier you were seeing is subroutines that call the routine that manages the pixel scrolling, which is what we're going into right now. And this is checking for the scroll count X to get the scroll counter to see the lines that are moving pixel by pixel on the screen. You may or not remember it earlier, but do believe it was back in the interrupt subroutine that we briefly covered that, and that's where the pixel scrolling was taking place at in the user-defined interrupt. So now we got the scroll left, right? So it's going to control the pixel scrolling to the left. And these are, again, our central variables. And here's our scroll counter X for our left position, being tracked by 4. Now we have the scroll up, right? And then we have the scroll count Y, which is our vertical up and down. Now we have the scroll down, going down the screen. Here's where the actual pixel scrolling takes place for the right, left, down, and up. You can see I have them in red here. Again, we're managing those by those variables, right? Can be used all throughout the project. Find pixel scroll going up. you can see now we're finally using the scroll count Y, and we're masking it so we can get this scrolling that goes from 0 to 7, since each character goes from 0 to 7. If you remember, I believe it was the first video I showed that in, I hope. I talked about it briefly. Each character is a small character on the screen. Like, for example, when you're seeing the first Commodore 64 display, even the ready prompt, when you see those individual characters, each of those, if you looked at them at a smaller level, they're made up of a small matrix, and they're counting from 0 to 7, going left to right, and 0 to 7 going up from top to bottom. And essentially, what's important here is you want to scroll through those pixels. So you could use this would be a great example. Let's say this is one of the characters here, and it's made up of all these pixels. You're scrolling through it, and you're scrolling through this one, and scrolling through this one, and that's how you get the screen scrolling across. And then down here, you'll see we got some first copy and vertical buffer going on. So we're keeping track of what's going on with the screen as it scrolls vertically. And this is shifting the characters up. Essentially, it's just moving the pixels up the screen. And this is drawing the up buffer, because each position, like we had the screen 1 and screen 2 buffers, now we're going to have buffers that control the up movement, the down movement, left and right movement. So we avoid that jerking of the screen again. And you can see this one goes into swept screen. Remember, we looked at that earlier. Now you see it's been used by this scrolling subroutine. And then here's our color shift up. And then here's our draw up color, which again, this now is just drawing everything up the screen here. And map Y deltas, I explained those in the first video. If you recall, those are just detected as the screen is scrolling up, has it passed a certain tile and arrived into another tile. So, for example, if you had a sprite on the screen and you were moving up, you could detect if you bumped into a wall. Find pixel scroll going down. This is just doing the same thing, except now we're going down for the pixels. You can see it mask it to a 0 to 7 count. So that's what this is doing. It's detecting this in binary. We got the lower nibble and we got the upper nibble. So you notice the upper nibble, which is those upper bits are not being used, but the lower bits are being used because we're just essentially scrolling through those pixels little by little. And you'll see a lot of repeat going on here. Here's our copy vertical buffer. Now we're shifting the characters down and drawing the down buffer. Now we're swapping the screens. We're going to color shift down, and we're drawing the down color. Like earlier we had the up, now we have the down. And you'll see again, here's our map tracking going on. This is very important. Whenever you're scrolling the map, you want to see what's going on with it, detect it at all times when you're moving the pixels around on the screen. And this is our map Y delta. And you can see it's masked to a value between 0 to 7. So if you remember from the early video 1, I showed how each pixel is set up and they're scrolling through it to detect whether or not you pass through a tile to reach another area of the screen. And it's just keeping track of those tiles as they scroll on the screen. Find pixel scroll going to the left. And this is using the left ones and masking those 0 to 7. And here we're copying the left buffer. And we're shifting the characters to the left, right? And we're drawing the left buffer. And now we're using our swap screens here, and we're color shifting the left, and we're drawing our left color. And again, you see our regular deltas being controlled. They're always going to be that 0 to 3. So I didn't want to go into a lot of explanation because this video is probably getting excessively long, but you can see there's more stuff going on here. So now it's decrementing the map X position because we're moving down, and it wants to be able to track each of these variables. Now this one is interesting because what this is doing is actually pulling the data to the screen here, and it's using this to track things that's going on as the screen is scrolling. See, if this map was scrolling and a character bumped into it, or if it bumped into a character, it would stop. That's essentially what these controls are set up for. Now we have our scroll right. Again, we got our scroll counters on the X register scrolling 0 to 7 pixels. And then we got our copy horizontal buffer. So you see a lot of repeat things going on here. And our shift characters right as the screen's moving to the right. and our draw right buffer to draw the characters from the buffer. And now we got our swept screens. We got color shift right and draw right color. Deltas again. See how we're always using the same thing here. We're always keeping track of what's going on. Now here's our shift characters up routine. I just wrote shift the characters for a scroll going up. Characters are moving down. And here's all the tables. If you remember earlier, the screen 1 is detecting where is it at on the screen. It was a table, and now what we're doing is we're actually drawing that screen here, real time. And here's our second one, our screen 2 buffer. Remember the front and the back buffer. This is keeping track of that data on the screen. Shift characters going down. This is essentially just doing this copying. As it's scrolling down, it's copying from screen 1 memory position to screen 2. Maybe I'll give an example of that later. There's going to be a lot more tables coming here. Shift the characters for a scroll in the left direction. Characters are moving right. Routines are unrolled for speed. So now we're shifting the characters to the left. And here's tables for that. Color shift left. Shift the characters for a scroll in the right direction. The characters are actually moving left. And here's tables for that. Color shift right, tables. Color shift up, tables. Color shift down. And now we're onto the buffer for the drawing up. Draw the characters in the vertical buffer to the top line of the scrolling screen. And this is going to keep track of what's going on with the screen as it's scrolling up. There's a lot of you can see again, we got our screen detection going on here between screen 2 and screen 1. And this one is taking care of the bottom line on the screen as it's scrolling down. It detects the bottom line here. And I do believe this is probably the one that's getting rid of that bad line. Now we're onto the draw down color. This is the color going into position. And here's the actual buffer taking place with our screen. And this is the real time drawing to the screen now we're looking at. Draw left color. Draw right buffer. Draw right color. Copy the data needed to the vertical buffer and vertical color buffer for edge drawing of new characters on the jump frame. So remember earlier we had our copy vertical buffer. So as we're going to the edge of the screen, this is using to detect what's going on. And it's going to essentially be able to copy our map as it's coming to the screen here and move it. So essentially if you're right here at the corner, right, and you've got these pixels, right? These characters going all the way up and down the screen, scrolling in pixels from 0 to 7. As it gets to the edge here, that's what this subroutine is doing. It's going to basically be able to copy those and pull them back into the screen. And this is actually a buffer that's going on here. And again, just for time's sake, I'm kind of skimming through a lot of this. So from here, we loop through the tile and copy the character data and the color data to the vertical buffer and vertical color buffer. Use the adjusted X delta as our start point because we won't always be on a tile boundary. Note, this is only for first tile, after which we will reset to 0 for a full tile. And now we copy the data needed to the horizontal buffer and horizontal color buffer for edge drawing of new characters on the jump frame. And this is still going through the same buffer. So we now have to address the tile in 0 page pointer 1. So now we have to loop through the tile at our delta X value for all 4 lines and copy the character and color attribute data to their buffers. Our first block lookup depends on the map Y delta, so test to see if there's a 0, which it should unless it's the first lookup. And there's just too much to really go into a lot of explanation on, so I'm just kind of reading through some parts here that might help make it a little bit more clear, hopefully. So split from copy horizontal buffer. This is the copy left buffer. And it's going to be very similar, except now we're copying everything over from the left-hand side. We now have the address to the tile in 0 page pointer 1, so now we have to loop through it and copy the data at a delta X value for all 4 lines in the tile into the buffer. We also need the color attribute data for that character, since we packed info in the upper half of that color byte. Our first block lookup depends on the map Y delta to test if it's 0, which it should unless it's the first lookup. And then this is the end of the actual scrolling. Now down here, you see these are the final variables. You saw earlier we had our scroll fit skip, which I believe that is the one taking care of the bad lines, just to see if we can't skip scrolling fix on stop. And this is our horizontal buffer, and these were our tables. So essentially it's separated by the X variable, or the X register. And this is our horizontal color buffer table. This is our vertical buffer table and our vertical color buffer table. So summary of topics covered. In this video series, you learned how user-defined interrupts are generated to run in the background while currently disabling system interrupts. The joystick was added to allow a user to move the screen around. Screen swapping is the process of copying the entire screen that is seen and placing it on a back buffer. Then the system can alternate back and forth between them quickly. Finally, both horizontal and vertical fine scrolling were introduced. Both map X and Y positions and map X and Y deltas were tracked to be used in collisions in a future session. Thank you for watching. I want to personally thank you for watching this series, subscribing to this channel, subscribing to my Facebook page, and just being here today. And I can never stress it enough, I always thank you guys for being here for me, and just feel free to share this video with your friends and whoever finds it of interest. Hello everybody, I want to thank you for having joined the Commodore 64 game project for video 2. In this series you learned how raster interrupts are stabilized on the screen and how you can essentially, when you stop the system interrupts, you can create your own user-defined interrupts based on whichever line you're at on the screen. And also we explored setting up the joystick, which will be used for the screen scrolling and eventually later for the sprite movement. And we also covered the screen swapping. That's between the front and the back buffer screens. It kind of takes a camera picture from the front to the back screen, and it's alternately moving back and forth pretty quickly to save that raster time. And finally, we explored the scrolling routine to see how everything works down at a pixel level. So guys, hope you enjoyed this so much as I enjoyed creating it for you. And I look forward to hearing your feedback you can leave comments on YouTube, but if you really want to stay engaged with me, Facebook is the way to go. I'll be trying to create a session where we can all kind of hang out very soon. Let me know if you have any ideas and drop them in the YouTube chat. I'd appreciate that so much. Until then, you guys have a wonderful day, and I hope this has been very enjoyable for you. Thanks for watching, guys.